In this video, I'd like to talk about exponential functions from tables and graphs. And with these example problems, we're either going to be given a graph or a table, and we'll need to determine what the equation for that graph or table is. So for this problem, we're told the exponential function f, whose graph is given below, can be written as f of x is equal to a times b to the x. So this is our general form for these exponential functions. And when we plug in 0 to our function, we get a times b to the 0, and b to the 0 is just 1. So a is essentially our starting value. It's the value, the y value of the function when x is 0. Whereas b is the base of the exponential function. It's the number that you multiply by to go from one integer x value to the next. And if the base is bigger than 1, we're dealing with growth. If the base is a fraction, we're dealing with exponential decay. So we just need to figure out these values, and we can do that by just looking at these two plotted points. Notice that when x is equal to 0, the y value is 2. So that tells us immediately that the function at 0 is equal to 2, or in other words, that is our a value, comparing it to our general formula. And the base, remember, that's just the number we multiply by to go from one integer x value to the next. So when we increase x by 1 each time, we multiply by that base. And so this point up here, notice, is at 1, 6. So as we increased our x value by 1, we multiplied by that base. So to find the base, we took 2 and multiplied it by that base, and we got back 6. So we can solve this equation to find that b, our base, is equal to 3. And from here, we can just plug in a and b to our formula. So we get that f of x is equal to a, which is 2, multiplied by our base, which is 3, raised to the x power. And to check this, you just want to look at some other point or multiple points on the graph just to make sure that this works. So let's look at maybe when x is minus 1. So f of minus 1 should be 2 times 3 to the minus 1. So that means we're dividing by 3 once, so this is 2/3. So it should go through the point -1 2/3, which fractions can be a little bit difficult to tell, but we can get a rough idea. And it looks like at minus 1 that it does go through right about 2/3. So that seems to make sense. And if you want, you can check further points just to make certain that the equation is right. But we can plug in 2 multiplied by 3 to the x power as our equation for this graph. And let's do another problem with a graph. And in the next video, we'll look at some problems with tables. So we have that the exponential function h, with the graph given below, can be written as h of x is a times b to the x, again our general form, where a is our starting value and b is our base. And in this one, we should expect our base to be a fraction since we have decay here, since as the x values increase, the y values are decreasing, whereas the previous example was exponential growth. So let's just denote what these points are. This has an x value of 0 and a y value of 4. So we know our a value. Since we know if we plug in 0 to our function, let me rewrite that as h. We know that when we plug in 0 here, b to the 0 is just 1, so you just get back a. And a, in this case, would be 4, since that's the y value when x is 0. Now this next point is at 1, 2. And remember that our base, that's just the number we multiply by to go from one whole number value of x to the next. So when we increase x by 1, we are multiplying by our base b. So we went from 4 and we multiplied that by b to get to 2 in this case. So solving for b, we get 2/4, which is a half, which matches up with what we expected because we did expect a fraction here. So now just putting these two values together, we get that h of x is a, which is 4, multiplied by our base, which is 1/2, raised to the x power. And just to double check that this is correct, let's look at maybe another value. Let's plug in x is equal to 2. So we have h of 2. We're going to plug that into our formula and see if it matches up with what's on the graph here, since we know it should go through at 2, comma 1. So when we plug in 2 here, we get 4 multiplied by 1/2 squared, and 1/2 squared is just a fourth. So 4 multiplied by a fourth, that's just 1, which is exactly what we expected, which means we can feel confident that that equation that we found is correct. So h of x is 4 multiplied by 1/2 raised to the x power.